Hello students, I hope that you have done sufficient practice of the topics that I have covered in my previous videos, like conditional probability, total law of probability and independent events. In today's video, I am going to explain about independent experiments. So, first of all, I will explain about the difference between independent events and independent experiments. And then I will discuss some examples on the topic. So, let us go ahead on the journey with the next topic, that is independent experiments. To understand independent experiments, let me take two examples. The first example is a card is drawn from a well shuffled pack of 52 cards and then a second card is drawn. Find the probability that first card is a spade and second card is a club. Club when first card is not replaced. So in the case when it is not replaced, you have already solved such type of questions. Let me solve it again to make you difference between the two examples. So in first case, as it is given, first card is spade and second is club, and we are getting first case of it. First example, first case. It will be like P, A, B, or you can say P, A intersection B, where I am considering A as spade. Let me write it over here. A as drawing of spade and B as drawing of club. So it is given that first is spade and second is club. So therefore its probability is given by 13 upon 52 into 13 upon 51, because it is the case when card is not replaced. Now the second case is P, A, B. The same case, first is spade and second is club, but the card is replaced. In this case, we are getting probability as 13 upon 52 into 13 upon 52. This already I have explained in previous video. And as I told you that second case is the case of independent events, whereas first case is dependent events. So this I explained in previous video when I told you the difference between independent events and dependent events. Now let us have a look on second example. It is a card is drawn from a well shuffled pack of 52 cards and then a second card is drawn. It's okay. Questions are same up till here. Now in second line we are getting find the probability that one of these card is a spade and other is club. Have you observed some difference? In previous case it was given that first is spade and second is club, but here it is written that one is spade and other is club. So the case may be like P, A, B or P, B, A. This is second example I am talking about. Because यहाँ पर उसने कहा है कि दो कार्ड जो हमने ड्रॉ किए उनमें से एक क्लब है और दूसरा स्पेड है. उसने ये नहीं कहा कि फर्स्ट क्लब होना चाहिए दूसरा स्पेड होना चाहिए. ही सेड कि एक क्लब और एक स्पेड होना चाहिए. सो द टू केसेस मे बी देयर, मे बी कि first card is spade and second card is club, or the case may be first card is club and second is spade. So here we are getting two options. So such type of cases when arise in the problem, then these are called independent experiments. This is one of the experiment that first is spade and other is club, and this is another case. So if two cases are there, then such type of problems comes under the topic independent experiments. So to solve this problem, we'll write P AB or means plus P B. Now as the same first case, when first ball is not replaced. So first card is spade, means probability is 13 upon 52, and it is not replaced, means the probability of getting club is 13 upon 51 plus it is 13 upon 52 for getting club and 13 upon 51 for getting spade. And for the second case, means when the card is replaced, the problem will be solved like 13 upon 52 into 13 upon 52 plus 13 upon 52 into 13 upon 52. So this is the difference between the questions which are from independent events and dependent events and the problems from independent experiments. You may take one more example that there is only one bag containing 2 red and 5 blue balls. So the question may be like 2 balls are drawn from the bag. What is the probability that first is red and second is black? In that case, this is the simple problem of conditional probability, and if it is written that first ball is replaced in the bag, it will be the case of independent events. But if the question is asked like 2 balls are drawn, what is the probability that one is red and other is black? In that case, we'll go with the same procedure, that is the procedure of independent experiments, and here we will deal with the case and or. Case of and or means intersection and union, or you can say multiplication or plus. So we will deal with the two signs in case of independent experiments. Now let me take more examples to elaborate the topic, to explain the topic very well. Let us read out this problem. It is the probability of student A passing an examination is 3 by 7 and that of student B passing is 5 by 7. So two cases are given to us. One is A probability of passing A in examination is 3 by 7 and passing of student B is 5 by 7. Assuming that the two events passing A and B are independent, means passing of A does not affect passing of B and passing of B does not affect passing of A, means the result of A and B are independent of each other. Find the probability of only A passing the examination, and the second case is only one of them passing the examination. I hope you understood that first question or you can say first part of the question is having only one option, and that option is like first of all let me write A is the event that A passing the examination and B is the event that B passing the examination. So it is given that PA is equal to 3 upon 7 and PB is equal to 5 upon 7. Now let us deal with first case. First case is only A passing the examination. What does it mean? The probability of only A passing the examination is equal to P A B naught, means only A will pass, B have to fail. It is clear from the question. So therefore, this probability is P. You can say, you can write this as P A intersection B naught, or you can write it as probability of A but not B. So you can understood in any way. This may be written A B naught, or A intersection B naught, or A but not B, or we can say probability of only A. As in 11th class, you have studied the difference between only A and A. So let me recall you this difference through Venn diagram. This is one of the set and this is another set we are having with us. So you know, if this is set A and this small circle is set B, then A is means the whole big circle A, but only A means we are talking about only the shaded region. This you have learned in your 11th class. So here we are talking only about A. Only A means the shaded region. So what does it mean? It means that B is not passing at all. So therefore, the probability of this thing is given by PA. It is given that passing of A is 3 upon 7. So passing of A is 3 upon 7 multiply by not passing of B, and passing of B is given to you as 5 by 7. So therefore not passing is 2 by 7. So we are getting 6 upon 49 as the result of only A is passing in the examination. So here we are getting only one case, that is PAB not. Now let us see at the second part. It is only one of them passing the examination. So what does it mean? Here we will be having two cases, and these two cases will be P, probability of only one of them is passing, will give us two options, either A passed, B failed, or A failed, B passed. Isn't it? These two cases may arise, and we can write it as P A B naught, or means plus P A naught B. So this can be find out like passing of A is given as 3 upon 7 and not passing of B is 2 upon 7, plus not passing of A will be 4 by 7, that is 1 minus 3 by 7, into passing of B is given as 5 upon 7. So after simplifying this thing, you are getting only one of them is passing. So it is the case of independent experiment where we are getting the two cases for the given problem. Here's the next problem. In tossing a coin thrice, find the chance of throwing head and tail alternatively in 3 successive trials. So again, we need to go with independent experiments, because we will be having more than one case when we are talking about getting head and tail alternatively, and these will be let me say H implies getting head and T is the event of getting tail. So according to the problem, probability of, you can say, let us name this whole experiment, whole event as E. We can write over here, E is the event throwing head and tail alternatively. So we can write PE over here, probability of getting E is equal to, I think you can write, this is alternatively, means first head, then second tail, and third, then again head. This is alternate, plus the case may be tail, head, tail. Here again we are getting alternative, that is tail, then head, then tail. So there we are getting two cases. It will be the case, it may also be the case like find the chance of throwing head in first throw, tail in second throw, and head in third throw. Then we will be having only one case. There will be no other case. So we need to make the cases as per the requirement of the question. And now you know very well that what is the probability of this thing. It is 1 by 2 for head, 1 by 2 for tail, and 1 by 2 again for third head. So it means we are getting 1 upon 8 over here, as well as the probability of this case is also 1 by 8. That's why we are getting the result as 1 by 4 for getting head and tail alternatively. Now let us take another example. It is a bag contains 3 red and 7 black balls. Another contains 4 red and 5 black balls. If one ball is drawn from each bag, find the probability that both are red, and second one, when one is red, other is black. Here we are having two bags. One bag 1 is having 3 red and 7 black balls, and bag 2 has 4 red and 5 black balls. One ball is drawn from each bag, one from bag 1 and one from bag 2. We need to find the probability that both are red. So let us suppose that A is the event of getting red ball from first bag, and B is the event of getting red ball from second bag. Let me name event E as getting both red balls. So we can represent, or we can write this solution as PE, means probability of getting both red balls is equal to PA and B. Means both should happen, that first bag से red ही आनी चाहिए और second bag से भी red ही आनी चाहिए. So therefore we can represent it as PA intersection B, or we can write it as PAB, as I explained in previous video as well. So therefore probability of getting red ball from bag 1 is 3 by 10, and from second bag it is 4 by 9. So we are getting 3 by 10 into 4 upon 9. Bags are different, so there is no case of replacement or without replacement. The events are independent. So after simplifying this thing, we can have the probability of getting both the balls are red. Let us take second case now. It is one is red and other is black. So we'll write it as, it is second case. In first case we have considered A as getting red ball from first bag. So we can consider A naught as the event of getting black ball from first bag, and B naught can be considered as getting getting black ball from second bag. So therefore, let F be the event getting one is red ball and another is black ball. So therefore, we can write PF as means probability of getting one red and another black ball is P A B naught plus P A naught B. Means what does it mean? That from the first bag we are getting a red ball, and from second we are not getting a red ball, means we are getting black ball. And this may be the case 1, or it may happen that from first bag we are not getting red ball, that is we are getting black, and from second bag we are getting red ball. So the two cases will be there for this problem, and it will be written as PA means getting red ball from first bag, probability is having 3/10. Multiply by B naught means not getting red ball from second bag. So it means it is 5/9. Plus here not getting red ball from first bag. It means it is 7/10. Multiply getting red ball from second bag means 4/9. So after simplifying this thing, you can have the solution of the problem, which is getting one red and other black ball. This question may also be asked like first ball is red and second ball is black. In that case, two cases will not be there. Only we'll take that first is red ball and second ball that is taken from second bag is black. So only one case will be there in that case. Now let me take one very interesting problem. It is A and B throw a coin alternatively till one of them gets ahead and wins the game. Find their respective probabilities of winning. Here A and B are playing a game in which they need to throw a coin, and whosoever will get head first will win the game. We need to find out their probabilities of winning. कि A के जीतने की probability कितनी होगी या B के जीतने की probability कितनी होगी. So I hope you understood the problem कि two persons are playing together and they are throwing a coin, और जिसका सबसे पहले head आ जाएगा वो ही game जीत जाएगा. To simplify this problem, let us start with the events E1 and E2. Let us say that E1 is the event that A throws head, and E2 is the event that B throws head. So the case is if A wins the game, then B will lose, or vice versa. Now let us say that A starts the game. Let A starts the game and wins the game. A ने गेम को स्टार्ट किया और उसने विन भी किया. हम यहाँ पर रिवर्स केस भी ले सकते हैं. लाइक वी कैन टेक दैट लेट B starts the game and win the game. So we can start from anywhere. So when we are taking this case that A starts the game and win the game, so then probability of winning A is equal to what? A starts the game means A ने coin throw किया first time पर ही and he win the game. So the case may be P even because even when A throws head. तो A ने गेम स्टार्ट किया और उसको हेड मिल गया, he wins the game and game finish. But this is not the only possibility. The case may be like P even not, E2 even. What does it mean? That even not means A starts the game but he doesn't get head. Then it is the turn of B. I should write here E2 because E2 is the event that B throws ahead. And here we are taking that A starts the game and wins the game. So therefore, when B throws the coin, he does not get head. Then it is the turn of A. He throws the coin and he get head. Means at second chance. But again, this is not possible always. The case may be like P even not, E2 not, even not, E2 not, even. मीन्स 3 बार ए ने थ्रो किया कॉइन को, उसका तीसरी बार हेड आया और हम क्योंकि लेकर चल रहे हैं कि विन तो ए ने किया, दैट्स व्हाई वी आर टेकिंग कि बी का हेड नहीं आया एंड दिस प्रोसेस विल गो ऑन टिल ए विन्स द गेम. So therefore, let us write the probabilities of this. Now probability of throwing head by A is 1 upon 2 plus again the probability of not throwing head, or we can say throwing tail by A is again 1 upon 2, which is again not throwing head, or you can say throwing tail by B is 1 upon 2, and similarly PE1 is 1 upon 2 plus now again 1 upon 2 into 1 upon 2 will multiply 1 upon 2 5 times, so we can write it as 1 upon 2 power 5 plus up to so on. Now this can be written as 1 upon 2 plus 1 upon 2 power 3 plus 1 upon 2 power 5 plus up to so on. Here we observe that this is a sequence with first term as 1 upon 2 and number of terms as infinity, and if we divide second by first we are getting 1 upon 2 power 2. Similarly, if we divide third by second we are getting 1 upon 2 power 2. So therefore we are getting a GP. Therefore we will write that the sequence is a GP with A is equal to 1 upon 2, R is equal to 1 upon 2 power 2 and N is equal to infinity. So you should know the formula that you have studied in your 11th class, that S infinity is equal to A upon 1 minus R. Means sum of infinity terms of a GP is A upon 1 minus R. Here A is 1 upon 2 and R is 1 upon 4. So we are getting 1 upon 2 upon 3 upon 4, and after simplifying this thing we are getting 2 upon 3. So therefore the probability of winning A is 2 upon 3. So winning B will be 1 minus 2 upon 3, that is 1 upon 3. So these are the respective probabilities of winning A and B. So this was about the problems based on independent experiments. I hope you understood the difference very well, and by reading the questions you can easily identify the problem, that which kind of problem is given to us, and you can simplify these problems very easily. In next video, I will explain about law of total probability. This topic will be very important for the study of upcoming topic, that is Bayes theorem, from which usually we are getting a question of 4 or 6 marks in the examination. So watch all the videos carefully to know the concept, to understand the concept very well, and then you will enjoy your studies.